Hi, and welcome back to Network Forensic Fundamentals. My name is Phil Hagen, and in this episode, we're going to continue a little bit more on talking about Wireshark as a core network forensic tool, but we're going to focus on the filtering language that are used in Wireshark for display filters. Display filters are very important to us as forensicators because it allows us to change the current scope of what we're looking at without modifying the underlying packet capture itself. This means that we can take an extraordinarily large collection of hundreds of thousands, maybe millions of packets, and narrow them down to a much smaller number that's more manageable and allows us to do more focused investigation and inspection. Now, the filtering language itself is relatively straightforward. You have a lot of very familiar operators, but you can use any of the Wireshark fields with those operators. Now, if you remember back a couple episodes ago, I said that there are over 250,000 different fields. That's a lot to keep track of, but I'm going to show you a trick in just a few moments here on how you can discover what those fields are called and which ones you're interested in. But as we start to explore those fields, we're going to maybe look for packets containing packets where a certain field is equal to a certain value. This is done with string comparisons or string equality. If we're talking about numerical fields, then we can do numerical comparisons with equalities or inequalities. We can also look for whether a certain field doesn't contain a certain value. So think of that as the inverse of what we talk about with inclusion. You can also get pretty creative. You can do set membership. So you can say, I'm only looking for packets where a certain field is equal to one of these few values. It's a lot easier than daisy chaining things on with and, for example. But if you needed to craft that, you've got and, or to combine things together. You have the not to negate. And we can use parentheses to enforce order of operations, which will allow us to kind of craft very complex logical evaluations. You can also do some pretty cool things with strings. You can look for substrings with contains. If you want to look for regular expressions, you can use matches. And to maybe cast or dynamically change what those are going to look like, you can cast a field to lowercase by saying lower, and then in parentheses, put the field that you want to transfer to lowercase. That's especially helpful when you're doing a contains search, though, because it allows you to look for just the lowercase version instead of having to look for all of the many variations of the different case-insensitive searches. There are many ways of using these and a ton of other filter features, though. So remember, if you're looking for that comprehensive documentation, Wireshark's own site is going to be the authoritative place there. But we're going to kind of walk through a couple of these here to kind of give you an idea of how to use Wireshark dynamically to your advantage. Probably the first thing that you were wondering when I said that there were 250,000 different fields is, wow, how am I going to be able to find which of those fields I'm interested in? The great news here is Wireshark's going to tell you right in the interface. I'm going to go back to the same PCAP file we've been using in the past couple of episodes, and I'm going to go down into one of these HTTP response messages. We're going to go here. I'm going to roll up the IP layer. I'm going to unroll HTTP, and I'm going to take us down to, let's say this content type field. This is one of the HTTP headers. There could be hundreds of these. But if for whatever reason I was particularly interested in maybe looking for other HTTP responses that matched what we're seeing here, I would want to build a display filter using this field. And if you look all the way down here, you can see in these parentheses, we've got the exact field that we're looking for. You can see here I've got http.content_type is now going to be the field name that I'd be looking for. So if I wanted to write a display filter, I can go up here to the display filter line and I can say http.content_type. I put two underscores in there. Content_type is equal to that text HTML. Or maybe I just would want to say contains HTML. And then I go ahead and hit return. It's going to parse that out. And now I see all the responses where that field, HTTP content type, somewhere contains the substring HTML. That's a great way for us to write those manually. But the good news is we don't actually have to. Let me go ahead and clear that filter here. And let me go back into the same location we were looking at before. I've got this field. Let's say I wanted to look for this exact header. I don't want to type that whole thing out, but I don't have to. I can use Wireshark to my advantage. Simply by right-clicking that one field, I can then say either apply or prepare as a filter. Now this is where it gets to be a little bit interesting, really flexible. Apply and prepare. Let's talk about the differences there. When I go ahead and say apply selected, you'll see that it's going to instantly go through and reparse that entire packet capture. Now, the one that I've got shown here, it's relatively small. It's only about under 100,000 packets, so the parse happens very quickly. But imagine if I had a gigabyte or a 2 gigabyte PCAP file. That could take some time. And if I'm filtering this many times, or maybe I want to say, well, I'm not interested in text HTML. Maybe I'm interested in something different, so I want to change this. If I want to modify that display filter, I'm going to have to parse it again. It's going to have to go through and refilter. So generally, my preference is to prepare the filter. I'm going to go ahead and clear this filter, bring us back to where we were. And I'm going to go back in, but instead of apply, I'm going to say prepare. Now, if I do the same option on the submenu, selected, you'll see that it did not go ahead and parse. It didn't refilter everything. If I wanted to refilter this PCAP file, I have to click all the way over here, or I have to hit return up in the box. Now, if I did that, it'll do just what you saw previously. But what if I wanted to augment, add on to the filter that I've just automatically created? What if I said, you know what? Not only do I want text HTML, I also am interested in adding in, let's see, what's a good example here? Let's say I'm just looking for redirects. So I'm only looking for status code 302. I can right click this, say prepare or apply as filter. And now you'll see I've got a couple other options that have appeared or become available. These are the and the ors. This will take and augment the existing filter. Now, I'm not going to do it, but if I were to select this option right here, it would replace. Same thing with not selected, it would be just the negation. But if I say and selected, you'll see that it has now modified that display filter up at the top. Still hasn't applied it, but it has at least modified that for your benefit. Now I could go in, I could modify this more if I wanted to, or I'm going to right now go ahead and hit return. It's going to parse through those, and now we're limited down to, in this case, just the 14 packets that match now both of those conditions. The or options will simply change these double ampersands to a double pipe. If you wanted to see what that looked like, we could actually just do that ourselves. And this will then logically change the and to an or. And now we see that not only are we looking at the text HTML, we're also going to be looking at any of the other 302 responses. So the second example here is a 302 response, but we have a different character set, so therefore the content type doesn't match our display filter. But it did for the second part, the 302 part, so it still matches. All of this together is going to give you an incredibly flexible, almost infinitely expansive filtering language that allows you to navigate through the packet capture at your convenience. Now, when you're writing your own packet capture, or you're writing your own display filters, it is going to get more comfortable over time. You're going to become familiar with the most useful or more commonly used fields. Those syntaxes and those operators are going to become a lot more memorized, a lot more kind of mental memory, or a mental muscle, if you will. But the good news is when you're starting to write these, Wireshark's actually given us a great way to very, very in real time, very quickly see if what you have typed in is valid. And you've actually already seen it. It has to do with whether that filter is red or green. And I'll give you just a couple of options here. Let's say I wanted to build a display filter that captures just a couple of values. I could do that with an or I could use set notation. We're going to take a look at how the syntax color highlighting is going to help us to do that. I could say http.response.code is in a list, and this list is a comma-separated set of values that we're interested in. Maybe I'm looking for 301 or 302. Those are two different kinds of redirects. You can see that it's turned green here, so when I hit return, you can see that now it's just going to contain those 301 and 302 responses. And you can see this over here. Most of these are 302s, but you'll see that 301 pops into there as well. Anyway, it's a great way for you to build these. Maybe I wanted to add some more on. Maybe I wanted to say, I also want to see any 206s. Those are called partial content. Now, Whether or not there's any in here, I'm not sure, but if they are present, we'd see them. Just a quick look over here in the info column. Doesn't look like we had any 206s, but if they were present, they would have matched. And of course, you can add on more and more and more of these. Maybe I wanted to look for errors where the client requested something that doesn't exist. That's the 404, of course. Lots of those are present in this sample. So now we can see how that set notation is going to work. I'm going to clear the filter now, and we'll take a look at another example. What if I wanted to do numeric comparisons? Maybe I want to look for only responses that are in the 200 family, so between 200 and 299. Now, I wouldn't want to use set notation for this because that's a very long list, but I can actually use numerical comparisons for this because they are numerical types. So let's go ahead and use that same value, the HTTP response code. http.response.code is greater than or equal to 200, and at the same time, I want to make sure that the http.response.code is less than or equal to 299. Now you can see I've established those two ends. I go ahead, I hit return. It's going to filter the file, and I'll have anything that's in that 200 series. Now in this particular data set, it looks like most, if not all of these, are simply 200, but it's good to know that I've captured that entire family that I'd be able to use for whatever purpose I might want. You can also see as I'm typing that the field names are being suggested. This is very similar to what you see with a lot of different search options or search engines, search features, I should say. Because if we go ahead, clear this display filter, bring it all the way to the end to reset it, I can see all of the HTTP dot options. And I just have to mouse through, or I could use the scroll to see all the different HTTP options that are available. And I'll draw your attention to one other thing that you may have seen. Simply typing the word HTTP means any HTTP field is found somewhere in that document, somewhere in that packet rather. And then we can say, here's only the content that says that it's got HTTP parsed out. It's actually a very convenient way to cast protocol-based filters. Even though Wireshark has almost 250,000 fields that are available, it doesn't mean that we can just make those up on the fly. It means we've got to use fields that are predefined. And we talked about before identifying those in the status bar down at the bottom in the parentheses. But let's say that you ignore that advice. And let's say that you just started to type any other kind of field that's not defined. I can't simply make up a field because it doesn't exist. Wireshark's telling me this through the use of that red syntax checking. Now, not only can I not hit return here, I can't even apply that because Wireshark says, hey, that's not syntactically valid. I can't apply it, so I'm not going to go ahead and try that. This also is going to give us indications of other reasons that the field is invalid. So let's say that I was looking for, again, that header that was the content type, http.content_type. And let's say I'm looking for this to be equal to text/HTML, and I forget to close the double quotation mark. You can see here, it's still red. And as an added benefit, if I look at the tooltip that pops up, it's going to tell me that it's an invalid filter. And if we look all the way down here at the bottom in the status bar, it tells me that as well. So I've got an idea of what the problem is. So this is a great way for you to use the user interface to your advantage, as especially you're exploring new protocols. There are other edge cases that you may run into as well. Pretty much anything that's invalid is going to show up as such and give you a good indication of that. But in some cases, you might get a little bit of a more cryptic, a little bit less useful error message. Let's say that we're looking in here, and I forget that I'm in Wireshark. Let's say I accidentally put in a BPF, and I say host is 219.51.61.74, whatever the number is. You can see that it's red because this is not a Wireshark display filter. However, it is a perfectly valid BPF. It's just that the display filter can't take a BPF. So not only does this show up as red, you'll see down below, it's telling me that something was unexpected in this context. This is an example of a probably less than great, less than super useful error message. It just means something's wrong and you should probably reassess. So don't think that it's going to tell you exactly what's wrong in every single case, but it does a pretty good job in most situations. That was just a little bit of scratching the surface on what Wireshark's various display filters can do for you. Feel free to grab any copy of Wireshark, or if you want to have a pre-packaged forensic workstation all bundled up, you can grab the Sans Sift workstation download and fire that up in your own VMware or other virtualization instance. And there's a way for you to now experiment with and to play around with all of the things that we've just talked about. As you're going to see in another module coming up pretty soon here, we actually have some demonstration labs that you can use to go through with your own Wireshark and get a feel for it. So I'll point you to those in a later episode, and we've got a lot of other good tool-based information headed your way also. Thanks very much for joining. Again, my name is Phil Hagen. This is Network Forensic Fundamentals, and we hope to have you back again soon.